In this video, we're going to take a look at linear search. So there's a lot of different search algorithms out there, but linear search is probably the easiest to go about understanding and implementing, and it's a good place for us to start. If we think about searching in general, it's probably one of the most important and useful things that a computer can help us do. So if you think about how you use a computer on a daily basis, you're probably doing a lot of searching. So you may go out on the web and search for music or search for a movie. Locally, you may search for a particular document on your machine. So searching really is going on a lot on probably a daily basis in terms of how you use a computer. So linear search, while it's probably not employed, by any search engine or probably even by, searching for a document on your computer, it is an important algorithm for us to understand. So this is the way linear search works. So let's take a look at this array that we have here, and it's a very small array. It's just a 5-element, and we'll say that it's an int array since it has all int values stored in each element. And what would happen is we would have some particular value we were searching for. So let's say that we were searching for 16. What would happen is that we would start at the very beginning of this array, so the element that has the index value of 0, and we would compare, is 16 equal to 10? And we find out that that's not the case, and then go to the next element. So sometimes linear search is called sequential search, since it just sequentially moves through each individual element in our array until finally we get to the thing that we're looking for. So the thing that we were looking for was 16, and we find this in the 4th element of our 5-element array, and at that point in time we could stop our search since we found the thing that we were looking for. Now, that's not exciting necessarily to just find int values, but it could really be applied to anything that we were looking for. In the worst case scenario with linear search is that we would have to search through the whole entire list. Now, in our case, the whole entire list would just be one more element. So if we were looking for the value 8, we'd only have to do one more comparison to find 8 over finding the value of 16. But what if we had a 50,000 element array or a 100,000 or a million element array? So that's a lot of comparisons that we'd have to do. Now, one of the cool things about linear search, or maybe the positive, a pro for linear search, is it doesn't have any preconditions. So there are search algorithms that do have certain preconditions, meaning certain requirements before they can actually perform what they're supposed to do. So take, for instance, a binary search algorithm. It requires the list or the array to be sorted. So we couldn't perform that particular algorithm on this list here. But that's not the case with linear search. Linear search says we don't really care. We don't have any preconditions. So the things to keep in mind related to linear search, just to kind of recap, is that it compares each element in sequence. So it keeps comparing until it finds the thing that we're looking for. It may be the case that the thing that we're looking for is not in the array. So in that case, we would have to traverse through and compare to every single element in the array before we find that out. It doesn't have any preconditions, and in the worst case, as I said, it just searches through the whole entire array, which could be quite bad. So the number of comparisons, the amount of work that's having to be done grows proportionally, at least in the worst case, it grows proportionally to the size of the array that we have. Of course, we can always get lucky and find the thing that we're looking for in the very first element of the array. So if we were searching for the value of 10, we would just simply perform a comparison on the first element, and we'd be able to stop. So let's go over to Eclipse and code up our own version of linear search. All right, so I've loaded up Eclipse. I've already created a project and also a CPP file called linear search. And I've typed in the common things that we have within the file. So pound include IOStream using namespace standard. And then I've also written a stub here for our main function. So what we want to be able to do is just create an int array and ask the user to input a particular value that they want to search for, and then we'll search our array using linear search to see if that value exists or not, and then indicate to the user somehow or another if we found the value or we didn't find the value, and maybe where we found it in the array. So the first thing we need to do is just create an array. So we'll do int, and we'll just call our array A, and we'll make use of the creation and initialization shortcut. So we'll just do int A, open square bracket, close square bracket, and then the assignment operator, and then do open brace and specify the values that we want to have in our array. So we'll say we have the values of 15, 23, 7, 45, maybe 87, and 16. So it looks like we have a 6-element array here. So we have that, and the next thing we need to do is just get input from the user. So we're going to get some particular int from the user to search for. So we'll declare a variable and maybe call it user value, which will hold what the user inputs. So then we'll do cout, and then the insertion operator, and then just say enter an integer. And maybe a colon space, and then another insertion operator, indel. So we'll have that displayed to the user, and then we'll do a cn extraction operator, and then user value. So just getting some stuff there from the user. I think before we write the function call for our linear search, we'll actually write the function definition. And I'm going to write it above the main function here just so it can serve as the prototype as well. So if we think about this linear search, you're probably thinking, well, we need to pass in the array to this function, we need to pass in the size, and we also need to pass in the thing that we're searching for. So that's really the search parameters. But what about what do we return from this function? So the thing that we should return is probably something that indicates where we found the value, if we actually found the value in our array, or a value to indicate that we didn't find it. So if we were thinking about where we found it, we would probably return an index value, which would be an int. If we think about maybe something that we could return if we didn't find it, that could also be an int. It would just have to be an int that's not a valid index. And really the first invalid index that you could probably think of is a negative value. So -1 would probably be a good value to return if we don't find the thing in our array. So the return type is just going to be an int, and then the name of our function will just be linear search. So let's see, linear search. And then we need to pass in some values. So the formal parameter list is going to just be an int array. So this should be fairly familiar to us from some of the other videos. And we also need to pass in the size. So we'll do int size. And then we have another key piece of information that has to be passed in. We've got to pass in what we're searching for. So we'll say that that's also going to be an int, since we're dealing with int arrays. And we'll say that the formal parameter is just going to be called search value. So really what's going to happen is whenever we call linear search, we'll pass in A, we'll pass in size 6, and we'll also pass in user value, which will just be known as search value here. Or at least we're going to be passing in a copy of that value to search value. All right, so let's go ahead and write the body. So do an open brace, close brace. So if you think about linear search, you need to be visiting each individual element of that array and doing a comparison. So in order to visit each individual element of an array, you need to think about that for loop that we've seen before. So we'll say for int I, assignment statement 0, so starting our index value off at 0, and then we'll say as long as I is less than size, semicolon, I++, we got to make sure we're incrementing our loop counter there, which is also serving as our index. And now inside the body of that for loop, we've got to focus on what do we need to do on each iteration. Well, on each iteration, we're going to be sitting at a new element, and we can compare that element's value to the search value. So we can just compare the search value to see if that's equal to the particular element that we're now looking at, which would be specified by the name of our array, which is called array, or array is an alias for our array A down here. So we have array, open square bracket I, close square bracket, and what we want to do is just see if, so we're going to write a condition here, see if this particular condition is true, and if that condition is true, we can just simply return the index, which the index value is just I. Now we have to worry about, well, what happens if we exhaust the whole entire array and we still haven't found the value? So at some point in time, I is not going to be less than size, and we'll drop out of this for loop. And in that case, that's where we'll return that -1. So we'll say return -1. So we need to have some indication that we didn't actually find the thing that we were looking for. We didn't find that search value. So that's really it with linear search. You know, what we're doing is just traversing through the array, comparing each individual element's values by doing array open square bracket I close square bracket, comparing that to our search value. If those are equal, then we just return the location of where we found that thing. If we go through the whole thing, we just return -1, indicating we didn't find it. So let's go back down to our main function here and finish it off. So what we're going to do is just simply call our linear search. So call linear search and pass in A, pass in 6, which is the size, and also pass in user value. So all three of those things need to be passed in to our function called linear search. And we know that linear search actually returns a value to us, returns some sort of int. So we'll have a variable over here maybe to capture that return value. So it'll just be an int variable, and we'll call it maybe just result. So we'll say result assignment statement, and let's not forget our semicolon over here. So that's pretty much it in terms of the function call. And now what we need to do is process that result that's returned to us. So what we're going to do is just test to see if that result is, a non-negative number. So if it's a non-negative number, we know we found the thing that we were looking for. If it is a negative number, -1, we know we didn't find it. So we'll just do a test to see if result is greater than or equal to 0. And if that's the case, we'll do something. Otherwise, else, we'll do something else. So let me write the else part here. We'll say else, open brace. And maybe the else part is the easier part to do. So I'm going to do cout, insertion operator, and then say the number, and then whatever number it was that we were looking for. So that's held by the variable user value. And then the insertion operator, and then we'll say was not found. And that's pretty much it for the else part if we happen to not actually find the value that we're looking for. The if part is not really complicated. It's just going to be cout, and then we just want to indicate to the user that we found the particular value and maybe the location, the index value of where we found it. So we'll say the number, and we have a couple options here. We could say user value, or we could say a open square bracket result, since that's the actual index of where we found that thing. Oops, I forgot the insertion operator. So insertion operator a open square bracket result, close square bracket, and then insertion operator, and then we can say was found. So the number, whatever the number is, was found at the element. We'll say the element with index, and then we'll just specify the index, which is held by result. And then we'll do insertion operator indel. And that's basically it. Of course, this line is probably a little bit long, so maybe I'll split this up over 2 lines. So let's go ahead and save that, and let me scroll down just so you can see that. So if the result was greater than or equal to 0, we'll just inform the user that the number, whatever their number was found at the element with index, and then specify the index that's being held in result. Otherwise, else, we'll just say that the number, whatever the number was not found. And if we've saved this, let's go ahead and build it, make sure it builds okay. So it looks like everything is building okay, and now we'll run it. So it says down here on the console to enter in an integer, and let's enter in an integer that actually exists. So let's say 87, since that exists in the array. And it says the number 87 was found at the element with index 4. So does that make sense? So this is 0, 1, 2, 3, and 4. So yeah, it returned the correct index value. So let's run it one more time and see what happens if we put in a value that's not in our array. So we'll put in the value of 25, and we see that the number 25 was not found. So that's pretty much it for this video. Hopefully you've learned about the linear search algorithm and how it works, and also understand that it doesn't have any sort of preconditions, so it doesn't require our array to be sorted like some of the other search algorithms that we'll look at. But we do know that it doesn't work so well whenever we have to maybe search a very large array. So if we had a 50,000 element array, a 100,000 element array, it's going to take a while to do a comparison sequentially through that. So if the value that we're looking for is toward the end of the array, or maybe not even in the array, then the linear search really is painful in terms of the amount of work it's going to have to do in comparison to some of the other search algorithms. But that's all for this video.